I want to start this video off by looking at a circuit board that is very similar to the one that we're going to be creating today. I'm recreating this because I want to make some modifications, including the addition of mounting holes and adding some new resistors to pull the transistors to ground when nothing's connected. This time I'm going to go through the whole process from start to finish on camera to show you. Here's a little video to get you interested. These LED strips are controlled by the PCB that we're going to make today. Alrighty, so to work on the circuit we're going to be using a piece of software called Altium Circuitmaker, and this is, as the name implies, made by a company called Altium, which is the same company that makes Altium Designer, which is a very popular circuit design software for enterprise use. Now this piece of software is more for personal use, and in fact if you make something in this you have to publish it in their database, and you can see here there's a bunch of projects that other people have made that I can download and look at the schematics for, and then if I wanted to manufacture that I could get the PCB fabricated and so on and so forth. Anyway, that's basically the only catch. There's no other limitations and this piece of software is free. Anyway, let's go ahead and make a new project. So they do give you 2 sandbox environments, and we're going to be using one of those. Those are basically projects that are not published in their gallery of projects, if you will. So I'm going to call this LED Strip Controller. Okay. Yep, LED Strip Controller. Maybe we'll call it 3 channel because it has 3 channels. Alright, sure. Okay, so now we're on the kind of project page here, and I'm not going to add anything to this, so I'm just going to save it. If you wanted to add a description or project images, you could do it there. Now I'm going to do open design, and this will take a minute, so I will cut that out. Okay, so I've opened the design here, and now it's opened on the sidebar. You can see it in the list. You can ignore this first one in the list. That was just me messing around. So the next thing that we're going to want to do is add a new schematic to this. So go ahead and do that. Now here we are in the schematic, and you can see in the sidebar over here that I've added these 4 components to my favorites. So I've already gone through, I found the components that I want. That's kind of a painstaking process, so I didn't want to have to show you guys that. Alright, so I'm ready to start putting down components, and I'm going to start with the MOSFETs because, well, I don't know, because I want to. And then I'm going to put down my Arduino connector. Oh, that's not the Arduino connector. Okay, that's fine. We can put down that. That's the screw terminal, and that's where the LED strip and power is going to connect to. Then I'm going to do the Arduino connector. Yep. And there is one other thing that I wanted to put down, and some resistors, but I'm not going to do that yet. I'm going to sort of wire everything else up first, and then we'll see where those go. Okay, so now I'm looking at this, and I want to get rid of all this annoying text that's on these components. So I'm going to double click on this and uncheck visible for comment. Now we're also going to want to give these labels. So this one is going to be Q1. This one's going to be Q2. Oh, that's not Q2. Yeah, Q2. This one's going to be Q3. And this is going to be J1, J2. This one's going to be J1. And this is important later in the process when we're trying to PCB, so what's all together. That'll be together. Okay. So now I think we are ready to start wiring things up. Now to wire things up, I'm going to push the W button on my keyboard. And the first thing that I want to connect is the gates. So these gates are going to connect to the header down here, the pin header. So that's pretty easy to do. Just connect these like so. 4 is going to be a ground pin, but we're not going to do that yet. And now we can move this around and they stay connected, so I'm just going to move that so Q2 has a straight wire going right down to it. And then we can also just drag this up. Okay. Next I'm going to do the sources, which are a common ground bus that goes across just like this. Alright. Then drain from each of these goes to one of the screw terminals on the screw terminal header thing. Okay. And these two are going to get connected together. 1 and 2 are going to be ground and power in. Then 3 is going to be power out to the LED strip, and 4, 5, and 6 are switched grounds for the LED strip. Okay, then this comes over to 1, and we're also going to bring this down and connect it to 4, so the Arduino can get a ground as well. It's important that all the grounds are common together in your circuit. Alright, so now I'm just going to do a bit of cleanup. I'm just going to drag these over just so that that's not overlapping with that text. I think that looks quite a bit better. Okay, so these resistors are going to be going from gate to this ground bus. So we have to think about the best way to do this. I'm thinking that I go right here. Alright, and then we can just go gate. Is that connected? No, it's not. See, there's no dot there. That means it's not connected. Oh, I think I can't connect there because the pin actually ends down there. Okay. Alright, there it is. There, now it's connected. Okay. So we're going to want to move the rest of these down as well. Okay, and like the other things, I'm going to turn this off and give them proper designators. Alright, so there is our circuit. It's done. We're ready to start working on the PCB. So before we start designing the PCB, it's important that we go and look at the fabricators that we're going to use to fabricate our PCB. This is the website that I'm going to use, PCBs.io, and you can see it's pretty cheap. 4 copies for $4 or less per square inch. That's pretty good. With free shipping, it's actually pretty crazy. So as I scroll down here, we can see the specs, and this is really important when you're designing your PCB that you don't violate these specs, because then when you get your PCB printed, like say you have 2 traces that are too close to each other and they can't print things that close, then they'll be connected and you'll have some strange circuit behavior that you won't be expecting because you're not going to get the circuit that you asked for. So it's really important that you follow their design guidelines. Now, okay, so these numbers here are the most important thing that we want to look at. So I'm going to show you how to enter those into CircuitMaker. Okay, so now that we're in CircuitMaker, I'm going to go to Design Rules. Then under Design Rules, Routing, and then Width. The minimum width for PCBs.io is 6 mils. 6 mils is really small, so I'm going to just keep that at 10 mils. That's fine. Okay, so next we need to make sure that the clearance is not too small. So PCBs.io's limit is 6 mils. It's set to 10 mils. Again, that's close enough. I don't really want it to be smaller than that. 10 mils gives enough space between traces, I think. Now lastly, we need to set the minimum hole size. And PCBs.io's limit is 13 mil. So I'm just going to set that to 13. Okay, now we're good on the PCB rules, and we can start working on the PCB. Okay, so the first thing that we're going to want to do is figure out what size we want the board to be. So I'm going to go to Outline. That's where you draw the board outline, if you will, and set the grid size to 100 mil. Then I am going to draw a line on the outline layer. I'm just going to draw it around a 1 inch by 1 inch box here. Oh, missed that last one. Okay. Alrighty, now I can select that, go to board shape, and define it from selected objects. Now here's our board. Okay, so I set the grid down to something more reasonable, and I'm going to go up to project and import the changes from our schematic. Now this is the list of, you can see that it needs to add these components, add these nets, and add a component class. We don't really care about the component class, but we need all the nets, and that's basically the connections between the components, and we need the components themselves. So I'm going to execute that, and there everything is in our schematic. Okay, so let's start laying these out. We're going to want the screw terminals right over here on the side. Good. We're going to want the pin header over on this side. Now we're going to want to put in our MOSFETs, and if you look at the rat's nest lines, this one connects down to the bottom of the header. The one on the top is ground because it can connect to either the screw terminal or the pin header itself. So I'm going to rotate this so that there's not too many things crossing over, and then let's do that for the rest of them. Them pretty close here. Also, I'm going to want to move them over so we can fit the resistors in, hopefully. Okay. Okay, there's those. Now let's try to fit. So this one connects to the bottom, so we're going to try to put that right in there, squeeze it in. This one connects to 2. Let's put that, So you need to decide whether I want that on that side or that side. I'm going to say that side. Okay, then last this. Okay. Okay, so everything is in place. I think we're ready. Let's move that over just a little bit. It's okay if it hangs over. So I think we're ready to start routing the traces. Now the first one that I'm going to do is Q1 here. So I'm going to push R to start routing traces, and then click on there, and it will let me start drawing out this net in the way that I want it routed. Okay, so there's 1 already done. 2 is going to come across and go up to there, but it also needs to connect right up to there. And okay, good. May as well give it some more room around there if we can, because this one's going to connect to ground, but we're going to do that later. And last is this one. We want this to come up. Yeah. Oh, why would it do that? Okay, so just come up and then over and around to there. Good. We're also going to want to connect it to here, so let's do that. Okay. So the 3 transistors are now wired up. And so next, let's work on the grounds. And for that, we're going to want a little bit thicker traces. So I'm going to go to Classes, and under Nets, we're going to want to add this one, which is the ground connector, J1, let's see, is that a 4? I think it's a 4. J1, 4. And we're going to put that, oh, sorry, we got to add a new class. So this one's going to be ground, J1, 4. And actually, let's make this a all power class. So power nets. Okay. So J1, 4 is going to be connected to that. Also, let's just connect all the J2s to that, because those are all power as well. Now, if we go to Design Rules and Routing width, we can add a new rule and say when the object matches a net class, power nets. Let's make it, let's do 50 and set the max to 52, so that works. Okay. Alright, so now we have, now if we start drawing these traces, yep, see they're much thicker now, so that's good because they're going to be carrying more power. These grounds not so much, but I think we're going to have space for it, so I may as well make them a little bit thicker. And I'm going to do this on the bottom layer. I'm going to do the grounds on the bottom. Since we do have a 2-layer board here, may as well use them. So that's going to come down, and we're going to connect all these together. Then that's going to connect over to here. Alright. And last we need to connect this up, and this needs to come over and connect to there. Good. Okay. So our grounds are now all connected, and the very last thing that we need to do is connect the middle pins of these up to here. And I'm immediately noticing that these are crossing over. So I think the easiest way to deal with these crossing over in this case is just to rotate this. Yeah, I like the look of that a little bit more anyway, but we're definitely going to want to have, we're definitely going to have to reroute that ground that I just did. No big deal though. So we can just bring this, no, that doesn't look good. Delete that. Okay, we're going to bring that down. I don't like that little stub that's sticking out there. Can I get rid of that? Good. Okay. And the last thing that we're going to want to do is bring these 3 over. So let's go back to the top layer. I can just bring them around like that. Good. Same with this one. Okay, and this one, can we bring it up through there? See if we can make that look a little bit better. Beautiful. Okay. Alright, so it looks like everything is all connected. Oh, almost forgot this. Easy to see that, but yeah, we can just connect that across. Alright, good. Okay, so lastly, I wanted to add some mounting holes to this. So I'm going to go up to Pad, and let's just place one there and there, sure. Okay. Now, if we go into these, we can set the hole size to, let's do 125 mil. And yeah, disable plating. So they don't need to be plated, they just need to be holes. 125 and not plated. Okay, move that over as much as possible. Alright, good. So now we have some mounting holes, and I'm ready to start working the silk screen. Okay, so first I think I'm just going to go through and delete all the text here. Except, actually, let's keep these resistor markings. These can go just right here. That'll look good. Okay, so you can see there's designator here. Can I just delete that? Yep, good. Okay, so these 1, 2, 3, 4. So I can't delete them. Okay, check. Okay, let's go those. Okay, good. Alright, and J1, I don't need that. I can get rid of that. I need to down here and uncheck lock purpose, so those are locked. Oh, okay. Let's just hide it then. Hide that one. Okay, good. Last but not least, let's get rid of these. Looks like they are locked as well, so we can just hide them. Good. Alright, so that's all the text gotten rid of, besides the resistors. Those are fine. Now, I'm going to want to go on the other side of the board. So to do that, we're going to switch to the bottom layer. We're going to go up to View and then Flipboard. Okay, so now we're looking at the bottom. And I'm going to start adding text down here. Okay, and in order to add the text here, it's going to be easier if I hide some things. So I can double click here and I can start turning some things off. So let's turn off traces. We don't need to see those. Let's turn off the top overlay. We don't need to see that. We can turn that off. There's nothing in that, so actually let's just leave it on. So we are going to want to see the drill guide because we want to see where the holes are. We can't put text over that. And yeah, that should do it. So okay, that's good enough. We can see the holes. We can see where the components are on the other side. Let's start adding some text. So I'm just going to show you how to do one of these, and then I'm going to add the rest of the text myself. So if I just add plop some text down there, then I can type something in. Let's do my name. And we're going to want to mirror this because it's on the bottom. Good. Okay, my name can go right there. Cool. Now I'm going to go ahead and do the rest, and I'll cut that out. Okay, so quick note, I did put these in the wrong layer. I put them in outline. We're going to want them to be in bottom overlay since they're on the bottom. So we can just double click on the text and change that really easily here. Okay, so now I've just done a quick visual inspection and it looks like everything's good here. I've added the silkscreen text on the front and the back. I've hidden the back, that's why you can't see it, but it is there. So I think this PCB is done, and if I push 3 on my keyboard, this is undoubtedly one of the coolest features of Altium Circuitmaker. I can view this board in 3D, and so yeah, you can see here that this is facing the wrong way, and that doesn't look too great, but it actually doesn't matter either because when I put this in, I can just put it in the other way. So yeah, that's not an issue. If I were actually trying to refine this and make it good, I might go back into the schematic and wire it differently so that they're all connected to the right pins. Or you could use pin swapping, but I don't know how to do that, so I am not doing that. And yeah, this is going to be fine. I can just put this header in the other way. That'll be good. And got our resistors. They don't have 3D models, unfortunately, but we can see they'll be fine there. And our unplated holes, they look a little bit big, but that's the standard size for mounting holes, I believe. So yeah, I think this is done. Now, I'm not going to show you how to export the files and upload them to your PCB manufacturer website in this video. I will be doing a second video on that, specific to PCBs.io, because it's a little bit complicated to export from Circuitmaker for PCBs.io. They seem to prefer Eagle files, and I'm doing this in Circuitmaker, obviously. So yeah, it's a little bit complicated. It is possible though, and it took me a little while to figure out, but I want to share that with you. I'm definitely going to do that in a separate video. Okay, so real quick, since we're only using the back layer for ground, I thought that maybe we should just replace these traces with a whole ground plane, and I'll show you guys how to do that right now. So if we go up to unroute, we can unroute this net. Oop. And then I'm going to go ahead and do a polygon pour connected to the net I just ripped up. And yeah, we're going to actually put that on the bottom layer. And let's just call this the ground. Also, yeah, this is all wrong. Okay, bottom. There we go. And let's pour over all same net objects. Okay. Now I just define the area as the whole size of the board. Like that, and then I hit escape. And you can see it filled everything in, and if I zoom in on this, you can see that it connected the pins of components that are supposed to be connected to ground. And if I go back and put the top layer on top, you can see that's still there. So now all the grounds are connected together through this plane that will be able to carry a lot of current. And that's good, since these grounds of these transistors are going to be feeding current back to this ground, and everything's just connected together. Low resistance. This is ideal. Alright, so like I said in the beginning of this video, I am doing a giveaway. 2 of these boards will be going to 2 lucky viewers, and maybe not actually that lucky since I don't have that many subscribers, so you have a fairly high chance of winning one of these. Just subscribe and leave a comment down below letting me know what you want to do with the board. I'm fascinated to read some of your ideas, and I will be picking the comment randomly, so it doesn't need to be clever, but I'd like to read some of the ideas, and if someone has an idea that's especially clever, I may just give away a third. We shall see. And yeah, it'll include all the components. It will not be assembled, but it will include all the components. Thank you for watching. If you enjoyed this video, feel free to give it a thumbs up, and be subscribed if you want to see my next video on how to upload designs from Circuitmaker to PCBs.io.